this one. Okay, so the second part is about variable classes. So we mostly talked about numbers and a bit about strings. And because the computer is a computer, it only understands bits, zeros and ones, and has a limited grasp of what is what. We have to treat numbers differently from strings, for example. So there are a few data classes that we have to talk about. That's numeric values, logical values, which are like true or false, characters and strings, and structures, cell arrays, handles, and I just added tables, which I haven't talked a lot about in other classes. Well, I actually did, but they are so good, so I use them more and more. And why do I tell you all of this? Because this is the boring part. This is where people think that programming is really boring. There are different data types. Who cares? Well, there are two reasons. You are dealing with research data, and it's only as accurate as you want it to be, and you'll have lots of data that you'll have to work with. And if you use the wrong type, everything will be really slow. So you actually have to wait for the computer. Even though it's super smart and super fast, when it uses the wrong data type, everything is slow. So, reason one, use the right type and you'll get efficient. Actually, in Matlab that's pretty easy. So you probably won't have to care much. Maybe the second reason is more important. And that is Matlab is picky, and if you make errors you'll get red text. And if you understand what the error message means, then you'll get faster at debugging. So you'll be able to understand the feedback that Matlab gives you. And starting with the numeric classes, we have integers, floating point, complex numbers. Complex numbers, sometimes I get confused with those, because I usually use the I, the letter, when I make loops, because I, for me, stands for index. But if I forget to make, I don't know, a semi or a colon or something, Matlab thinks that it's a complex number. And it usually takes some time for me before I realize that, okay, I get it now. And I don't deal a lot with complex numbers in my daily life, so I also forget that they exist. So when I make a Fourier transform and I get something out, I'm like, why are there so many numbers? Okay, the second ones are complex. Oh, okay. I don't care. Because that's the phase information, so I can just throw it out many times. And then we have special cases, infinity, and when we don't have a number at all. So there are two examples. 1 divided by 0, I think that's infinity. And 0 divided by 0 is not a number. And not day numbers, that's why I use for missing data. So a lot of the time I make error bars with I have a mean, I have a standard deviation, and I have a group, like I have maybe 80 persons, but not all of them have enough data. So I make a check. If they have less than 3 valid trials, for example, I set their output to not a number. And we can now just quickly switch to Matlab and say that A is make a random, what did we say, 80 persons, like that. And if A is smaller than 0.2, they are too bad, so we set them as not A numbers. Can actually do like this. I just created some dummy test data. And if I want to make an average and a standard deviation, so I can make a bar out of this. If I take the mean, I will get not a number, because if I sum them together, I will get not a number.
So we need to exclude it first.
So if I do that, I get a number, but if I add not a number, I get not a number. And if I want to calculate a mean on all the values that are not in there are a few different ways to do that. But many functions have a none. If you just type none before the command, it will skip the not a numbers.
Okay.
So I
So
do,
filter out.
yeah. So that's, it's a really fast way of working with missing data, or thresholding your data. If we make a figure, if we make a line out of this, you will see that there are gaps in the time series. So I work a lot with eye tracking data from with infants. And infants, they tend to look away at sometimes because they are interested in the lamps or in whatever else is going on. And then we get gaps in the data. So we have to make sure that, we have enough looking time and that the quality is good. And adults, they blink, and then we get gaps in the data. And of course we could fill it in, but if it's 1 second of missing data, there's so much happening during 1 second, so it's better to keep it as a gap and handle the gap instead.
Could you use the not a number persons if you would, for example, like to see if they deviate on some other measure than the persons who are above the threshold? For example, if you had age, then you would see one mean for the not a number people and the age for the okay people. So to use that as an independent variable.
Okay, so I made a variable called score, and we got an age. So they can be things. What else have we got? Maybe that's enough.
No, yeah.
Okay, so I want to find the ones that have not a numbers. So one way of doing that, I'm wondering how, I'm not sure how you would do it. I know how to do it, but I don't know what is the logical way of thinking. We quickly get into this kind of...
Yeah, maybe it's just takes too much time.
But let's do it like this. Let's just see what I would do. I would say that we would have some index to some people where we have not a numbers. There is a function called isNone, which will tell you. It's a logical, value, 0 or 1. So it's either true or false. So if we do that, we get a logical array with all the subjects that have not a numbers. So if we want to look at the score of these, you can just type score parentheses idx, and we see that all of them has got not a number in there. And if I make the opposite and take all the ones that don't have data in there, we see that then we can make sure that we actually did something right. Okay, no one has got not a numbers. Very good. And then we have the age. Then we can use this index. This is the age of the ones that didn't have data. And this is the one that had. So we can look at the mean. Oh, actually, bit of a difference. That might be significant. So let's try.
That's the reason. The young ones, they can't manage.
No, it's not significant. Sorry, can't publish. So that's.
This is being fluent in Matlab.
Yeah.
That's my goal.
That's
This
my
is-
goal,
yeah.
Yeah, but
I think you know the grammar. That's the
Yeah.
thing.
exactly.
Yeah, we're only doing the words right now, aren't we?
Yeah.
Vocabularies.
So
Single letters.
Yeah, we'll get there. We'll get there.
I think. Did you understand what I was doing? You haven't seen most of these commands.
No.
Like
yeah.
isNaN. You haven't seen it before,
No.
but it picks out the ones that has not the numbers or not. You haven't seen this one, the tilde sign, which means the opposite. Mean, did you know that? I bet you got it, I think. And then you had t-test 2, which sort of makes a t-test of 2 independent groups.
And the index.
What?
And the index. The index.
Yeah, this one was a variable that I created using isNaN.
Oh, so okay, so the
So-
actual name was just could be whatever.
Yeah.
Yeah.
Ah,
So I was doing this. So taking the
yeah.
ones who had not the numbers in the score variable and picked out those from this one with the parentheses and the indexing that we learned during last lecture. So it's actually a one-liner to make a t-test between 2 groups, depending on their data. That's nice.
Yeah, cool. Okay.
Cool.
Yeah.
Okay, you got it. When you saw it, but it's very different from putting these
Yeah.
pieces together.
Getting there. Yeah.
Yes, I know
Yeah.
that it's a really big thing. Okay, so that's the numeric class, numbers. Special case, infinity and not a number. Very seldom run into infinity. But not in numbers. They are always there for me. Logical classes, we talked about them. And we had 0 or 1, but actually nothing is equal to 0. So if you're, for example, testing, I don't know, that could be another way of storing missing data, though I prefer not a number in front of empty brackets. But anything is true. So in an if statement, if you're saying if this is true or not, you can actually say if 5, then do this. anything but 0 and empty brackets equals to true for Matlab. So something is good enough. So this is often used in conditional statements. If it is raining, then bring the umbrella, otherwise put on your sunglasses. Then you make an if statement. If raining, true, then I do this. Or if it's not raining, then we should do this other thing. And in the example we just had, we made a conditional value or a logical value for every participant. Do they have missing data or not? 0 or 1? And I use it a lot when I index groups, just like we did now. And it's fast, super fast to do that. Much better to be able to do that than to loop through each individual and check, is it not a number or not? Characters and strings, they are, every character is an integer coded by a number code, which is the ASCII code. And if you go to the internet, you can find ASCII tables, and there you'll learn that, for example, ASCII code 65 is a capital A, ASCII code 13 is enter, and so on. And when you make a string, you have characters in a string, in a vector. And they must be enclosed in single quotes. So if we try this versus this, we'll see what happens. And you can he. Then Matlab thinks that he is a variable, but we haven't defined it, so it doesn't work. But if we have single quotes, Matlab stores it like that. I think you can, if you do like this, ABC, if you convert it to a double value, convert it to numbers, we'll get the ASCII code out of it. So here is a list of the different, some of the ASCII codes that exist. So letter A, capital A is the top of this row, it says 65 here. It's not very often you have to think about this. You used to have to do that when you programmed a lot. But nowadays I think it's most for fun to make ASCII art or so on. It's really nice. I think one of the bonus tasks is to create your own ASCII art.
ASCII art. It's a new word for me.
Yeah. Okay. So, multidimensional arrays. We talked about vectors, a vector and a matrix, and array is just an umbrella term for all of these numbers or whatever that is stored in a huge mass of data. So if you got one number, you can have one number or you can have one character, but as soon as you start to put them together, so you've got several in a bunch, in a collection, you've got an array. And you can have many dimensions. So if you just have one dimension, that's a time series. It's just a sequence of numbers or whatever. 2 dimensions could be, well, you've got X and Y, like a spreadsheet, and you can plot it as an image. 3 dimensions could be a 3D brain image. 4 dimensions, brain image over time, and you can just add as many dimensions as you want. Should we try that? And make a 5-dimensional space and set the value to 40. Oh, yeah, we defined A as then we've got a multi-dimensional thing.
What does this mean?
What does it mean? Yeah, our brains usually get stuck after about 3 dimensions. So 5-dimensional space, it's 5 dimensions.
But is every single line a coordinate within all of those 5 dimensions?
Yes.
Yeah. But why
And
are
it-
the 2 first commas? We only get
Yeah.
the coordinates.
We can
of 3 of them.
let's start by doing this. First of all, is B anything? Yes. B. B. If we do B10, index 10 of B, if we set it to be, I don't know, 6. Look, Matlab adds zeros to this. First of all, I think that's just really scary in a way, because that means if you're defining something, for example, if the first 4 persons in your test didn't have any data, so your loop didn't add any number for those, but then you had a person with a score, you can get like numbers that you haven't told anyone that these should be zeros. If anything, they should be not the numbers. So that's good to know. That Matlab can add. It will fill up the space. So if we make it 2-dimensional, fills up with 0. We still got this 6 on the first line, but since we added a number down here, so it fills up the space. Let's make it 3-dimensional. Okay, so 3 dimensions could be viewed as 10 slices of this. So here are all our slices. So the first one is with the 6 and the 7, and then it filled up everything so it could make number 8 and the 8.
So you can sort of imagine them stacked behind each other or something. Or
Yeah.
on top. I mean.
Exactly. And if we continue, now we got a lot of stacks on stacks, and that's what happens if you do this. So we just got a really long list of things here before we see what is going on. And let's go back to the what should we do? We should do like that. So this is how we represent the data. But Matlab doesn't care about how many dimensions you have. under the hood it's just a series, a sequence of numbers. And to get that sequence, you can use the colon. And then you will get all of the values in your array as a row. That can be really handy sometimes. Can't find a situation right now.
Didn't you use that before when you had the matrix with not a number, and then you wanted them all in a line to overlook it? Where is it? Did you?
Yeah.
Maybe you did something else.
I did something else there. I already had a vector,
Yeah.
but I had them as columns and I transposed them.
Okay, that was just a transposition.
Yeah.
Okay.
And to transpose, you have the small citation
Right.
thing. Then you will get them as columns
Okay.
instead. Well, actually, yeah, transposing is quite important because Matlab usually tries to match. If you have 10 values in a column and 10 values in as rows, if you want to add them together, I think Matlab might figure it out. Not really. So maybe this was not what you wanted, and then you have to transpose one of them. Yeah. I don't want to confuse you, but I think I just did. But I think it may be a good example of those small details that are fluent for me. It's not obvious, and it's just a matter of a small, it's just a few pixels in that one, and it makes the whole difference. And both of these things work, but they give you so completely different output. So I think that's the tricky part about programming. But going back to the multidimensional arrays, I added a warning slide. Expanding variables by index adds zeros. That's what we just did. You saw it in practice. And expanding variables by index takes a lot of time. You didn't notice because, yeah, it was quite fast. But if you do this, it can make really a big difference in performance if you have it in a big loop. And then it's better to, if you know how big your matrix or array will be, you can just set a value at the end, and it will create all of it once, and then you can fill in. That's much faster than making it bigger and bigger. Oh, yeah. So knowing the size of your array is really good. There's a command for that. Size. And you can also flip them left, right with flip LL, or up and down. Flip UD. I think flipping left and right, I do that a lot when I make confidence intervals, because then I plot the mean plus the confidence interval over the mean, and then I take the mean and subtract the confidence interval, and then I plot it backwards and up and fill it. Looks super good. Because then you can have transparent confidence intervals in your plots. But we can get to that later. So more about indexing in your multidimensional arrays. So if you want to get one row or one column, you use the colon sign. Like this. So this means take all the rows from column 1. And if you want to have this is the first row and give me all the columns. So that's important. I do that very often. And of course, if you have multi-dimensional arrays, so for EEG data, I often have the channel, EEG channel, and I've got the time point in a trial, sample, and I have a trial number in the 3rd dimension. So if we imagine that we have this structure of the data, then we want the event-related potential as, well, for channel 64, we take all of the channels, all of the samples and all of the trials. And we want to create a mean out of that.
And 64 would be a person then? Or
What?
is 64
It's a channel number,
Okay.
channel number 64. And we do that, we take the mean over dimension 3. Then we take a mean of all trials.
What does that mean?
Because you have 3 trials, or?
No, the
Oh,
third dimension.
What does that mean? The 3rd dimension?
So that's the trial number.
Trial number,
So the first dimension would be channel.
okay.
Second would be the short time series over every trial. So this just picks out all the trials in the 3rd dimension, but we want to get the mean out of it. So
And the data?
the data is
And how do you call the data? I mean, you import before?
yeah, exactly. That's something I got from before.
Okay. We haven't talked about it yet.
Yeah.
Okay.
We'll get there.
Right.
And we can use the end command to, if you want to work backwards. Or actually, I often do this, although it's really slow, is if we want to read another person, we can just put them at the end plus 1. So that's nice that we can do that. It's very flexible. In other languages it's more difficult. In some other languages. And I think we did this already. Find values and set them to not a number because they are impossible for bad data. So for a pupil size, if it's smaller than 1 millimeter, it means that we caught a blink. So if you want to remove things, then you use the empty brackets. So this means take the first row, all the columns, and set them to nothing. Then they will disappear. It's a matrix, 20 by 20. A first row should disappear. Now we only got 19 left. Because we set all of the values in the first row to nothing. So now we talked about how to store things. The problem is if you want to mix these things together, like in a spreadsheet. Names of the subjects in one column and their IQ in another column. It's very difficult to do that. If we do like this, we have the first row, the first column is doesn't work. Why? Because per is 3 numbers and this is only 1 number. So that won't work. And to solve this problem, we have something called cell arrays. And that's like a matrix, but you can have different values or different classes, data types at each index. And this is what it says in the help. Each cell can contain any type of data. Cell arrays commonly contain lists, text strings, combination of text and numbers from spreadsheets, text files, or numeric arrays of different sizes. So how do we use them? The curly brackets instead of the ordinary brackets and the hard brackets. So should we try this? Copy that one. PowerPoint changes automatically. So now we could store strings in an array. So if we can index it, we can do it like that. But we can also do like this. Index with curly brackets. And then you won't get the cell back, then you will get the content of the cell. It's a minor difference, but this is where I make most of my errors, I think. Because if you want to compare a string, you need to compare the string and not the cell. Well, actually you can do that. You'll end up with having problems if you don't distinguish these two.
The string, the content of the cell.
Yeah. There are some other commands where you can transform these things. But I think it's really nice to use the cell arrays. I often do like this. I have a group of typically developing children. I have a group of high risk who did not receive ASD, autism spectrum disorders, and I have high-risk infants which eventually receive the diagnosis. Then I can loop through these groups. And I can, I don't know.
You could do like a t-test of some information that's,
Yeah.
I guess,
Okay, let's
No, no, that's it. But, I mean,
yeah.
yeah.
So then I would make a figure and I want to plot 3 bars, for example, 3 mean values. Then I could get the y data by, this is not a very good example, but I would take my groups and pick out the current group, which the first time is TD, then this group, and then finally this one. I sneak out of the problem by doing this. I have a separate function which you don't see now. Then I would make a plot of that would give me a loop through the different groups that I have and plot the mean value, and I would probably plot all the participants as well. So in this case it's really nice to have cell arrays. And I usually store all my data in a structure where I have where I tag all the subjects so I know which group they belong to, and then I can find them very easily. And structures is what comes after cell arrays. And they are we're putting more and more into our variables. So structure can just contain other variables, and we use them to structure our data. And I use it to group relevant variables like this. Subject 1, 2, 3. Like that.
So this is the structure, subject is the structure.
Yes.
And then it
So-
has in variables. Internal.
Yes. So let's see what happens if I do this in the command window. Clear all. I don't have anything in my workspace right now. Yeah, okay. It's the same thing as last time. But it did something anyway. Let's see what I've got in memory. I've got a variable called subject, but it's only 1 in there. That's bad. It's only Clara.
Oh, she's the only one with correct.
Yeah, it managed to do this and this, but failed at
Very
this one.
failed.
Okay, so let's do this now. Now we've got 3 subjects. Subject 1, subject 2, which has a different reaction time, and subject 3, which didn't have any reaction time, so it's empty, but we got an age. This is like 6 years ago. 7 years ago. It's got an image, And it's got a profile, which is another structure. So how can we get all of this data? Well, if we do like this, subject 3, and name, dot name, we get the name. Got the age, and we got the profile. Then we got into the structure within the structure. So structure are good in that way. You can sort of nest them into each other. And if you
sorry, if you would have any other information apart from username, could you sort of ask, okay, so in subject 3 dot profile, what other information is there?
so it's only
Okay,
got,
so it
but
gives
if,
us the answer.
so we can add into an existing structure just by inventing a new variable name. And, yeah, that's really good. Let's give subject 3 an age, because it, yeah, I had, what
Reaction time.
reaction time. I didn't have anything, so let's give me something. If I just type subject reaction time, it will output, it will loop through the structure and give me all of the reaction times. That's nice, because often I want to do that. I want to check my test score and see if they have none, and then I want to go back and compare the age or whatever. But when they come out like this, I can't take a mean value of 3 individual values. It doesn't work. So we have to take all these 3 values and put them in a vector. And we can do that by adding brackets like this if we want a test score or reaction times like that. If we take the name, it will just put them together. And we didn't want that, right? For names, we wanted to have them as cell strings.
Curly brackets.
When you make it into a vector, will it remember which value is associated with which person?
It's always in the same order. So, for example, if we want to output the name of all the ones having lower than reaction time 100, we can do subject, all the subjects where the reaction time is below 100. No, this one is in place, like that. It's already pretty tricky because there are so many hidden loops in here, what it's doing. But it's very compact and it's really fast. And I think when I get a variable that looks like this, like a structure, it's very easy for me to know what kind of data we have from all the participants. And you know what is a good thing? There are tables, which are spreadsheets. So if you have an Excel sheet with data, you can read it into a table. And a table is a structure, but it's sort of rearranged. People didn't get structures as well as, or as good as they got tables, because most people have Excel or SPSS in their head. And okay, that's the same thing, but let's make a new data type called table so that people don't have to adjust their thinking. So in this example, I'm creating a variable called table, which reads a spreadsheet and then converts it to a structure. Okay, in this example you can do it in other ways, but with this new structure we can take all the EQ values with hard brackets and find the ones which are below. Oh, actually, we remove the rows in the spreadsheet where the IQ is too low. We just excluded some subjects because we're in our exclusion criteria, and then we make it back into a table. Tables are very good because if you want to do more complex mathematics like linear mixed models, then you want to have a table that fits with that function. But I think of structures and tables as exactly the same things. This is the last data type. It's a long lecture about data types. And that's handles. I don't think I will talk much about them because I don't think we have the need right now, but we'll get into it later. And as it says, a handle is a reference to an object, which is sort of like a structure, but it also has some functions attached to it. So for example, a figure has a lot of functions that you can do with it. You can change the size and the colors and everything, but you also have values for everything. And to keep track of all the windows, Matlab store these things as objects, and to get to a specific window to sort of index them, you get a handle. And you can store these handles, or you can get these handles through some specific functions. They are in your list of commands to know till next time. But I can show you just what it looks like. If I type figure, I get a figure. If I make another figure, I have two figures. If I want to plot into one of them, but not the other, what do I do? Well, I click in this one, and then I can plot. Yeah, you can do lots of things, but sometimes you want to keep track of them. And what you don't see here is that the figure command actually gives you a handle. Figure, like that. So even if this window is active, I can get the other window from code by typing figure H1. So by storing these handles, which you get, you can control where your graphics are, for example. And if we use the command get for this handle, we can see all of the interesting things about the figure that we can do. So example, we've got a color, and we can set it. So if we take H1 color, it turns red. Or if we take position, move it. What else do we want to do? Well, we want to detect key presses. So if we make an axis here, okay, plot. Oh, that's bad. Like that. If we now click somewhere here, if we want to know where we're clicking, I think we have H1 current point, right? Yeah, and if I click here, it changes. So that's good. And then we have functions like what happens when we press the button. What happens when we move the mouse button over this figure? What happens when you press the a key on the keyboard? And these things that you get from using the handles, you can start making really efficient interaction with your plots and figures. So you can go through data quite easily and you can create your own tools that work the way you want. And not having to, for example, EEG lab, it's just miserable because you have to click 3 times to get the plot of one person or one trial, for example. And you know that, oh, I have to plot 3,000 trials. Click, click, click. That just takes too long instead of just pressing space or whatever. Next, 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 next.
Alright, so you could set, so for example, the Windows button down function. You would insert that and set that that's equal to doing this. So when I press down, I want to do this within the figure.
Yeah.
Yeah.
Within every figure, not just this one, figure
With
3.
this
all
one.
figures, this one, this figure
This,
3.
this figure. You see, we didn't get any color change on this figure, for example.
Also specific to the handle.
Yes.
Yeah.
So many people are very sloppy, including myself. I type figure, and then I plot into this one. If I want to get to the red, there is no way for me to get the handle of that in an easy way unless I click on it, because when it's active, I can get the active figure by typing get current figure or get current axis, because all the objects that you create have different properties. So you can change the line width or the line style. Let's go back to this one. If we plot it okay. But actually there is a handle received from that. Okay. So we can set the line width to 4. Oh, it's thick. And the line style to something like that. And then you can start formatting your graphics in the way that you want. So you can actually make, I make all my article figures directly in Matlab. So I can adjust them to...
Instead of editing directly to the figure.
Yeah, you can,
yeah.
it's possible to double click here, but
Yeah.
you know, it's, I make the figures and they look really nice, and then I send it to the other authors and they say, well, you know, we need to take out we need all the participants with 5 trials, not 4. Then you have to sort of sit and reformat everything, but if I already have it in the program, I say, sure, I'm super fast, and I just change one number, bring it back to that. That was actually quite a lot. I think we'll stop there.